Good afternoon, everybody. Welcome to Ellensburg, Washington, USA. In the month of May, we're late in the month of May, and I'm glad that you're still with us, still joining us for these Geology 351 sessions. There's just a few left. Get them while they're hot. The local time. Hello, Ariel. The local time is 12:45, I guess, 12:46, something like that, and we will begin the second of 4 sessions on magmas during the Eocene, between 60 and 40 million years ago. So, as is customary, I think my mouth is working today. Let's visit with a few folks. We have Ariel grabbing her handout. There's just one today. Emma is here. The rest will trickle in soon enough. Whatcom County, Odense, Denmark, San Jose, California, Dartmouth, Nova Scotia. I spelled my name wrong. Woodinville, hello Bob and Kathy. Eric in Virginia, Squim, Glasgow, Scotland, hello Gordon. Gloucester, Maine, or Massachusetts, I guess it's Massachusetts, all right. Bloomington, Indiana, Richland, Washington, Patrick, hello Patrick and Teresa, or Therese. I've never said hi to your mom, Patrick, that's weird. Hello Patrick's mom. First time for everything. Backcountry Gary from Darrington. Enjoyed your post recently, Gary. Beautiful photographs. Jerome is in Portsmouth, Virginia. Florida. Costa Rica. Central Point, Oregon. St. Louis, Missouri. Lake Oswego, Oregon. Madison, Wisconsin. Garrett, the Dutch Night Owl from the Netherlands. Robert, Barcelona. Austin, Texas. Calgary, Alberta. Sydney, no, hello from Thailand via Sydney, Australia. Wow, Rod, okay, I'm not even sure I follow that. Hotel Papa 100 from Switzerland, what up, homie? Selenian Block, age 70. Kirks in Sweden, Pittsburgh, Pennsylvania. Topak, Arizona. South Wales, UK. Cologne, Germany. Yarmouth, UK. Hello, Stephanie. This will never not be fun. Double negative. Nick Zentner's enjoying this. Third Person Thursday. Delaware Basin, New Mexico. Cleveland, Ohio. Andre from Dutch Caribbean. I'm not sure. Is that the Caribbean, or what is the Dutch Caribbean something else? Sorry for my ignorance. Burns Lake, British Columbia. Teresa and Patrick. Sauber. Hello, Sauber. Maine. Okay. Looks like we're doing okay. Finland. Hello. All right. Wonderful. I didn't even take a sip of my water, man. I got to hydrate. I got a good one for you today. I think I got a good one. Matthew's here. Oh, he's collecting like crazy. You're collecting playing cards back there. I guess you weren't with us last time, huh?
I was not, unfortunately.
Busted. Dutch islands in the Caribbean. Thank you, Eric. The Dutch bit of the West Indies. You know, I have struggled with where the West Indies are. And I like geography. All right. So no Vinmans today. I think we all need to take a break from eating Vinmans. Vinmans Bakery, you got to love it. I got to pop the chat out live like, oh, no, wait. Oh, okay. So I'm in a screwing around mood here. Let me, you remember the bottle of wine we got last time? which we are saving until the end of the class, and the students and I will enjoy this together. Those that are of age, not on campus, got it. All right, I got you covered. So Jim in Colorado, I'm going to come in real tight because I would really like this to be the little thumbnail image that shows when you scroll on the thumbnail for this show. And it's usually Vinman stuff, but it'd be fun to have this one show up. So I'm trying to trick YouTube into grabbing this for the little, do you even know what I mean? Like after this is posted and you hover over the little thumbnail postage stamp for this show, there's usually a little, just a couple of seconds worth of whatever the video was. And it's usually me holding up cookies or something. I'm trying one more time. Jim, thanks again. I can't wait to share this with the students. Same one. But there is one new thank you, and I think it was a gift from me. Isn't that right? Rick in Federal Way, south of Seattle. Thank you, Rick. The box arrived at the house. I know these are for probably me and Liz, but I'd like to share them with some of the students. So I don't know how to do it democratically, but let me share with everybody what these are. Rick ordered, it's hiking season, says Rick. And so Rick says there's a really great little business called Heather's Choice in Anchorage, Alaska. Heather's Choice. HeathersChoice.com. This episode of Nick from the Classroom brought to you by Heather's Choice. You got to love it. So Heather's Choice has freeze-dried items for your backpack, and also these packaroons, spice cocoa packaroons. You add water to these? A macaroon for your backpack. I'm sorry, I didn't take the time to read. Let me. 1, 2, 3, 4, 5, 6. So there's 6 of these. Oh, maybe I'm not going to share them. Heather's Choice, meals for adventuring. Heather says, packaroons were one of the first recipes I ever developed with my small home dehydrator. You will love these delicious treats on or off the trail. Heather's Choice on Instagram, Twitter, and Facebook. All right, I'm not sharing these. Thanks for the gift, Rick. Liz and I will enjoy these on the trail. Hope nobody heard what I just said. They're not. They're copying down their outline. Tuning me out as per usual. What's up, Bryce? Tim, you feeling better today?
Yeah.
Good.
I'm actually alive.
Okay, we had guys on the field trip yesterday. They had their second jab the day before, so they were on the field trip but hurting. So Matthew has intensity in his eyes. What does it all mean, Matthew?
I realized last night that I forgot to turn the homework last week. Yeah. It was like 11 o'clock on midnight last night.
Oh, classic senioritis from Matthew.
Is it okay for reduced whatever? Yeah. Okay. I appreciate that. I'll get it to you by the end of the night or tomorrow, if that's okay.
By the end of tonight or tomorrow.
Thank you.
Thank you, Matthew. You're a senior. Oh, the Holy Trinity. Hey, man, we're going to use your Corbally Canyon dike specimen just briefly today. So thank you, Rachel. And we're saving your boyfriend sample till next week.
You don't have to talk about him.
Oh no, I could write a book. Oh, Jess is here.
Yeah.
Mary's here. I feel like I want to go visit with everybody. So I assume everything's going okay with us. Can I double check one more time? You know what? No, I know what I'm doing. So we're 5 by 5. I'm not crackling. I haven't had a crackling mic in a while. Rhiannon, 5 by 5. Thanks, you guys. Thank you. Okay, hope you enjoyed today. Well, we'll see, but I think it might be okay. I'm optimistic, shall we put it that way? All right, I'm going to go visit with the student.
I don't know in California. Yeah, I don't know if that's a good thing.
I mean, obviously it's a good thing, but I don't know.
I got an email from Michelle yesterday out of the blue, just right after you talked about Michelle Harris that morning. Kind of weird. And I emailed back and I said, Rhiannon's doing really well. And she replies, well, that's cool. I don't know who Rhiannon is, but I hope Ariel's doing okay. I'm like, God damn it. I meant Ariel.
That's awesome, though.
So, yeah, she wanted to know about sending somebody on to study paleontology, and she knows this is not the place for that. I didn't have a good answer for her, but it was a weird coincidence. Yeah. You're good. I just came up with the wrong name. Hello, Ryan.
Hey.
Jess, how are you?
Good. I just got back from Alabama.
You're kidding.
I had to go to Alabama for my best friend's wedding.
Oh.
So I flew down there and came back.
Oh, my gosh.
Yeah.
Was it worth it?
Yes, it was good. It is
Good.
pretty crazy because it's like a few weeks until my thesis defense, so it's like crazy bad timing.
boy.
Very inconvenient. They didn't put my thesis defense into consideration, figure out the date for the wedding.
Wow, and yet you're here.
Yeah.
Well, that's dedication. You don't have to be here, obviously. Well, good. I'm glad you're here. Well, thank you. Well, so where did you fly in?
Nashville is the cheapest airport. That's what I always use
Yeah.
for getting back over there because I live in North Alabama. So it's about a 2-hour drive.
You used to live down there?
I grew up there.
Oh, you
I
did?
moved here
Oh, I didn't know
in
that.
like fall of 2019.
Oh, wow. I don't hear an Alabama accent at all.
I know, that's what everybody tells me.
Yeah. Well, you've assimilated quite well. You're talking like Bryce. He's a local.
I never talked like that even when I lived down there though.
Oh, really?
Really.
Well, I wonder why.
My mom did not want me talking like that.
Okay. Very good. Well, it looks from a distant place too, like, I don't know, 5 blocks off campus. Yeah, that's
exactly.
exotic. Yeah,
Very distant.
that's right. Well, look at you. You got everything out ready to go. Who knows what we're going to use today?
Knowing you is.
Knowing you. Tim has his orange.
How you doing today, Nick?
I'm doing fine, Bryce. Today might be good. Might. I'll share with everybody, but I just couldn't find a way to do this until like a few hours ago, and finally kind of clicked a little bit, kind of like that. It's all clicked into place. Oh, Tim can read the board. Nice, good reading. Yeah, burn. There's Kyle. So we're never going to see Andrew again, I'll bet.
Yeah, because he's leaving soon, isn't he?
He's swinging through. Our arrangement is he's going to swing through Ellensburg on Sunday on his way to moving to Pocatello, and he's going to take the final exam in my backyard on his way. So it's a little unorthodox, but we made it work.
Hey, it's been an unorthodox year.
It has, right. So why not?
Whatever
why not
works
just
to this point.
Exactly. Yeah.
I think he should be here in the summer a little bit. Like after, I think he has time in between
Oh, is he coming
field
back?
camp
Yeah.
and the start of his master's.
I suppose so. Yeah.
Yeah.
Well, he'll be sky high after that experience. That field camp in Lost River, that's outstanding. So
Is it?
he'll be. I'd be shocked if he was not into it. I'm sure he will be.
I didn't either, but I put it on there anyways.
Okay.
A lot of like resources I didn't actually use, but I put it in stuff.
Yeah.
To be quite honest, I really used USGS for the most of it. Howdy.
Oh.
Just stand here with a
Like-
microphone. That's all. Just kind of capturing whatever.
How weird shit happens.
You can say anything right now.
I don't know what they're talking about. I was pulling up my paper.
We're talking about
I was ignoring them.
Oh wow!
Because
I
you
see your nose popping.
She
right
just
out
threw
that
you
mouth.
guys under
I'm
the
not
bus.
even
Wow,
sure.
look at that. Oh boy. Oh boy. Oh boy. Good afternoon, friends, and I do mean friends. By this point, we are close friends. And I want to say right up front before I move on to the content today, this group has been one of my favorites, maybe ever. I mean, just for a bunch of reasons, coming off the pandemic, being here face to face, going out in the field together. It's a new format for me with 351. I used to just do one lecture a week and then we'd be out for an extended field experience. I like this 2-hour lecture format, so I'm probably going to stick with this routine in the future. But anyway, I just wanted to thank you. It's been a great experience, and we have one more week to go after today. We have a holiday weekend coming up, but let's really put the time in. Let's put the energy in with this session. And I don't have to pump you up too much because you guys have been dedicated all the way along. So I have one more thing that has been slipping my mind for the last week. We finally, did anybody notice, we finally pushed through the refund for your course fee. So you were all charged, does anybody know the number? Is it $85? $80. And did you see that refund come through in the last week or two? So it takes forever, God knows why, but I feel better that that's finally money back to you. And I know that you've been paying for gas. Those have been coming regularly, but hopefully there's kind of a weighing out option. I don't know how it pencils out, but you saved $85 by not paying a course fee and not buying a textbook either for the class. So hopefully we can all feel good about that. Okay, Bryce, the energy is good. So let's go ahead and jump right in. This is part 2 of 4 sessions. I have one rule today, and it's the same basic rule I had last time. Please, there's no talk of tectonic plates today. There's no tectonic models. There's no interpretations. I know we all want to do it. We all want to jump to it. We all want to talk about why this stuff is happening. You know the game plan, I think. This week is looking at the data that we have, courtesy of Jeff Tepper and others. And we're going to hold up. We're going to get there, I promise. Next week is going to be just fun and games with all sorts of models and diving plates and breaking plates and migrating triple junctions and the Yellowstone, all that. Please hold off. Stay disciplined today. Would you mind? Okay. That sounds then like this is going to be just kind of a meat and vegetables thing. I think I have something that's going to work. I worked on this lecture yesterday morning, didn't like it, wasn't clicking into place. I tried again after our field trip last night, still wasn't happy. Woke up at 3:30 this morning with Challis Magmas on the brain. I wish I was exaggerating, I'm not. I couldn't get back to sleep. Like, what am I going to do at 1 o'clock today? So I Zoomed with Jeff Tepper this morning, and he broke the ice for me and helped me find something that might work today. So, with that in mind, I'm pretty pumped, putting pressure on myself. Let's do it. We start with a Zach Galifianakis reference, between the 2 arcs, not between the 2 ferns. And the Challis Magmas are between 2 volcanic arcs, the Cascades Arc and the Idaho Arc. We've been introduced to the Challis Magmas from last time, but I've got some new ways to think about how the Challis fits in with other magmas in the Pacific Northwest. Then we get formally introduced to Jeff Tepper, who was with us live last time. And Colton, if you want to monitor, he's with us again today. And he might be checking in occasionally. Might even have a real-time question for him. And Colton might be the mouthpiece of Jeff. We'll see. And Jeff helped me with some geochemistry. You know that I'm petrified of that. He helped me with some geochemistry to help us compare and contrast between magmas from an arc, I'll explain, and our Challis magmas. And then finally, I hope today we will land on one of the most dramatic reveals that Jeff got me interested in this topic. Poorly constructed sentence. There's something called an age sweep in Eastern Washington that I want to show you. In fact, that's the handout that you have. So you already see the age sweep. I'll give it to you in a second another way. But let's go ahead and do the first part of the outline first. That seems to make sense. Feeling good today. Feeling good. The mouth seems to be working. So let's make hay while the sun shines. let's do it this way. This is the thing I couldn't quite get straight on how I wanted to deliver this. So this you recognize. I didn't erase this from Tuesday. All these crazy circles. What did I say so far? Collectively, those are known as the Challis Magmas. Now, once upon a time, and in fact, I think it's still used by some, once upon a time, those Challis Magmas were called the Challis Arc. In fact, I was in the field with Brian Atwater on Saturday, no big deal. And at some point he said, well, what are you interested in up here? And I said, well, I'm thinking about the Okanagan lately. He's like, why? And I'm like, oh, I'm thinking about these granites and other magmas with my students. And he's like, oh, the Challis Arc. I don't know anything about that. And I'm like, I don't even think we say Challis Arc anymore. He's like, what? And then, I said, well, I need to read a little bit more. I don't know, Brian. I'll get back to you. So we don't want to say Challis Arc. You'll see why, I hope, in just a second. Arc implies a certain set of chemistries and a certain set of map patterns. Oh, hell, I'll say it right now. An arc, like a volcanic arc, is a line on a map. Remember our back arc and our fore arc and all that? So we have a Cascades arc, and notice I've got a new number for you. We've casually said the Cascades started 40 million years ago. Now we're being more precise with Jeff's work. 44 is the beginning of our Cascade arc. We're extending it back 4 million years. But let's put the Cascade, oh, why not? Let's do the colors. We know we're the Cascade arc here. This is Washington, Oregon, Idaho, Montana. We know the geography. I'm going to put little volcanoes in here too, 17 of them for the Cascade Volcanic Arc. There was no Cascade Volcanic Arc. There was no pink until 44 million years ago, and we still have them, of course. Some of you went up to Tim's cabin after we did our field trip, and you saw high enough to look north to the Stewarts. Could you see Rainier or anything on the west? Yeah, okay, so that arc is still there, man. Okay, breaking new ground. If we go older than the Challis, older than 52 million years ago, there was a volcanic arc. He goes to his notes to make sure that I can draw this as carefully as possible. The Idaho Arc. Something like that. And what am I drawing here? Stratovolcanoes. And you're like, what? You're drawing composite cone volcanoes? Yes, I am. Well, I don't remember seeing a stratovolcano at John Stockton's house in Spokane. You're right, you don't. Because the Idaho Arc has been dead for 52 million years. But if we go back earlier than the 52 million year mark, we can get to some of those Idaho arcs. Now, if there's anybody watching at home who's an Idaho batholith fan, that's what I'm talking about. And there's actually two very different generations of magmas in the Idaho batholith. There's an older set of plutonic rocks. I'm talking about the Idaho batholith, which is part of the old Idaho arc. The Atlanta portion, don't worry about it. That's between 98 and 67 million years ago. And there's a younger portion of the Idaho arc called the Bitterroot lobe between 75 and 52. So my point is, if you've heard of the Sawtooth Mountains in central Idaho, Stanley Basin, Redfish Lake, that's all older granites that are the remains of an older volcanic arc called the Idaho batholith. Not our topic. So our topic, as you learned last time, is very carefully and specifically in this window between 52 and 44. The rest of our class is not even going to 60, not even going younger than 44. It's between 52 and 44. Okay? We're calling these the Challis Magmas and not a Challis Arc. Why? Well, oh, go ahead. I'm sorry. I was just kind of go ahead. Because they're not aligned. Perfect, Megan. That's our first point. So we're going to compare and contrast, remember, between two arcs? So pretty much this whole day is looking at a igneous rock from a pluton or a volcanic deposit and asking ourselves, is this magma from subduction or not? Is this magma from an arc or not? I think you all know. Do I need to draw a picture for it? What the hell? I'll do it. We know what the picture looks like. We know what the plate tectonic cross-section looks like. If we have a volcanic arc like the Cascades, Farallon, or today Juan de Fuca subducting beneath North America, making a chain of composite cone volcanoes. I am saying, this is, can you even see this? This is a little plate tectonic cross-section of another volcanic arc earlier than 52, and you're like, well, what is that? And why is there a volcanic arc so far inland? We're not doing that till next week, right? But we have evidence of a quote-unquote well-behaved volcanic arc in blue that shows all the signs of arc activity. So Megan answered our first way to tell the difference between arc magmas and not arc magmas. Not arc magmas mean the Challis. The Challis are everywhere. The Challis are these blobs that stretch, and I'm not making it up now. You heard of Sturgis, South Dakota? Ryan, what happens at Sturgis? Motorcycle, yeah. The Sturgis is right next to the Black Hills. You know, the 4 presidents' heads, Mount Rushmore. That's the country we're talking about. It's not even on this map. That's how far east it is. There are Challis Magmas in South Dakota, Montana, Wyoming, Idaho, Oregon, Washington, British Columbia. This is a widespread area. And instead of a well-behaved line of magmas, we've got this kind of scatter of blobs on a map. If this lecture works today, I lay out all this stuff and you go, I wonder why that is. I wonder why that is. I wonder, I'm trying to figure it out. And you know, fine to do it mentally, but we're not going to have that discussion until next week. Some of you are already probably 4 steps ahead of me. So everything in yellow is our Challis magmas, including the Teanaway that many of us were looking at yesterday. I want to do one more thing on the chalkboard with this chalkboard, and then we'll move it and try something next. Wooden blocks. Hanging wall, footwall. Crustal extension. Hanging wall goes down. What kind of fault? Normal. Thank you, drones. Crustal compression. Making earthquake. Hanging wall goes up. What kind of fault? Reverse. Crustal compression, crustal extension. Crustal compression, crustal extension. Cascade arcs. That is a crustal compression story. We do have reverse faults. We do have folds that are a direct result of an ongoing compressional regime that Washington has experienced in the last 44 million years. Am I ignoring the clockwise rotation? Sure. We're just trying to make this as simple as we can. In blue, volcanic arc, convergent plate boundary, compression again. Plenty of reverse faults from this time, older than 52, that are not only helping us see that we have a volcanic arc, a line of magmas, but we have lots of folds and faults also telling us this crustal compression story. Here's another reason that the Challis Magma episode is noteworthy. It's the opposite. You could see this coming. We have amazing normal faults in response to crustal extension, pulling the blocks apart, hanging wall down, making grabens. Do you know that term, graben? Like a Horsten graben, those are old-fashioned terms, but still used, or a half graben. That's all in response to this crustal extension. Uh-oh, Daddy's going to the whiteboard. We got a whole list of stuff that is a result of the aftermath of Silesia. Oh, I'm violating my own rule. Basically, what I'm doing is making a list of stuff that happened during Challis time. So I'm kind of violating my rule by mentioning Silesia, but we kind of know that's the backstory for this lecture, or this whole class, really. Has anybody heard of a core complex? Anybody? Does anybody want to try to explain or mention or give a vague idea? It was a real, it also came up in my conversation with Brian Atwater, actually. He's like, yeah, he said, yeah, back in the 80s, everybody's talking about core complexes. I'm like, you're right. I haven't heard much about core complexes lately. I guess I'm not hanging around with the right people. Anybody? If you haven't, I guess that's testament that we're not teaching much about them these days. But that was a big deal back 30 years ago. Nothing? I think I want to draw a picture of it real quick. Is it worth it? No, it's not. I'll do it verbally. Oh, no, I got this. Hang on. If we take a close peek in Northeastern Washington, and we'll be back hopefully by the end of today's lecture, between the two arcs, Northeastern Washington. What are any towns come to mind? Dinky little towns in Northeastern Washington. We're north of Spokane. Anything? Republic. Kyle, there's some high spots there. Go ahead. Newport. Deer Park. Sure, why not? This is a very complicated geologic map north of the Columbia River, pretty much in northeastern Washington. I doubt anybody can read this, including the people at home, but I'll read it for you. Republic Graben. There's a big old basin up there that formed between two normal faults in response to crustal extension during Challis time. There's a whole nother one called the Dakota Creek Graben. So those two orange things are places where the floor is dropping, a bunch of sediments are accumulating. Sound familiar? Like the chum stick, kinda, but I don't think there's strike-slip motion on these guys now that I mention it. There's a bunch of plant fossils up near Republic. That's maybe why you know Republic and the Stone Rose story. There's a bunch of dinky areas up here that I don't know anything about. I've barely been up in the Okanagan or northeastern Washington. But my point is, in addition to these grabens, there are these enormous core complexes. This is called the Okanagan Gneiss Dome. It's a core complex. It's a metamorphic core complex. I'm reading the names because I don't know these hardly at all. Kettle Gneiss Dome. Gneiss is metamorphic. Tim wants to ask a question.
Are core complexes where you get, like, as you have extensions, you have mantle coming up, and, like, is this like
violating the rules? I got you. I'm cutting you off. Tim wants to talk about mantle already. Let's just keep it at this level. A metamorphic core complex is a place, maybe a county or two wide, that's the scale of this, where you take the overlying brittle rock and you slide it away on normal faults. The crust is extending. You're taking the upper plate, as it's known, and it's brittle, and you make earthquakes, and you just slide that upper plate away. And what is revealed? The metamorphic rock that's down below, and this stuff comes up. Not necessarily mantle, but again, next week we'll get into it. My point is, these metamorphic core complexes were mysterious until 30 years ago, as I understand it. And the core complexes scream extension. That's my point. They scream, my God, we're revealing all this metamorphic rock that should be in the subsurface, but it's at the surface. What did I just say? Okanagan Gneiss Dome and Kettle Gneiss Dome and some others as well. So they are also part of our Challis story, even though, please don't get it twisted, the core complexes are not magmas. I'm saying we're revealing metamorphic rocks that are also part of this story, happening at the same time as the geologic elevator. And since I'm going crazy on the whiteboard, why not? There we go. In my mind, the headline event for an aftermath of Silesia, again, violating my rule, are the freaking Challis Magmas. All this stuff is happening simultaneously between 52 and 44. Matthew.
This may be violating the rule.
Go ahead.
The extension into, like you said, South Dakota. If we're seeing the Challis Magmas all the way to South Dakota, do we see that same extension?
That's not violating the rule. Good job, Matt. Matthew says, so if we can follow the Challis Magmas all the way to South Dakota, can we find the normal faults? Can we follow the core complexes all the way? I don't know Northern Rocky Mountain geology very well, but I do know that there are some of these beautiful core complexes in southern Idaho. That's where I first learned about them. Can I come up with one right now? The Albion, I think, the Albion Range. I'm going to embarrass myself. The Pioneers, I think. I slept through half those field trips with Dave Rogers. And I think there's core complexes in Montana as well that are Eocene in age. Maybe Wyoming too, now that I say it. So I'm going to say yes, even though I really lose the details as we go east. I like this. You're engaged. We're bringing up all sorts of interesting thoughts. Even though we're not doing the plate tectonic modeling, we're just kind of talking about age patterns and geography today, kind of. Ryan. What the hell? Everybody's going to raise their hand and say, I'm going to break the rule, but go ahead.
I don't really get how this works. So if you're getting crustal extension at the same time that you're accreting Silesia.
No, shutting you down. I could call that one a mile. I saw you coming a mile away, Ryan. Please wait. Don't take it wrong. Please wait. I want to lay this out. You got Tim?
I was curious about the Albion Range. Is that City of Rocks?
Yeah, near that. City of Rocks, but I got to hesitate. I'm not sure those granites are Eocene, but okay. You know what? This is a good. Before we leave this, I just wanted to do this very quickly. I did it for myself, and then maybe it's helpful to you too. I'll do it quick because I'm not sure it's going to be helpful. I jotted down every place name I could find with all these emails and notes that I took over the last couple of years. I was working on this, by the way, in March of 2020. I had the auditorium downtown booked. I had the filming crew ready to go. I had the lecture ready, 600 people ready to come, Farallon Plate, then the Pacific Northwest. Then, of course, everything got shut down. So I haven't really thought about this stuff since March of 2020, 14 months ago. So it's like full circle for me. Like at the end of this crazy run of all these live streams and everything else. What did Chris say at the party yesterday? I've made did he say 200 videos in the last 14 months? That can't be right. I have a problem if that's true. Rhiannon and I have a problem? I have a problem. I need an audience. What? Yeah. It's just, I mean, I've been really into this YouTube thing. And my point is, I haven't thought about this stuff until then, and I've just in the last 24 hours I've been having a blast because this stuff is really freaking cool. We'll get on with it then. So, how wide-reaching are we talking about? I mentioned South Dakota. Here we go. Half for the viewers who are watching from these places, and they're like, "Oh shit, really? My own little whatever." Bear Butte at the Black Hills near Sturgis. Bear Paw Mountains, Montana. This is all stuff that has Challis Magmas no, it's just Challis Magmas. Central Montana Alkali Province. Devil's Tower. The Challis Magma. You know Devil's Tower. Absaroka Volcanics in Wyoming. I mentioned those last time. Dillon Volcanics near Butte. Lowland Creek Volcanics. We're still in Montana. Near Bozeman. Trapper Peak, northern Idaho. Yes, the Challis Volcanics. There truly is a little town, a little mining. Hello. Gold and silver. Remember, I mentioned is almost every one of these is tied with some sort of precious metals. There is a little mining town called Challis, Idaho. And so we're naming this whole far-flung thing after one little area called Challis, Idaho, and the Challis Volcanics. Clarno in Oregon. John Day country, part of this story. British Columbia, the Kamloops magmas, the Francois Lake Igneous Complex. I'm just reading names. I don't know anything about these places. And then we finally get to Washington, where Jeff Tepper has done all this work. I won't point because it's such a small area, but I'll go northeast to southwest. Sherman Pass has Challis Magmas. Keller Butte, Cooley Dam. Grand Coulee Dam is made on granites from this time. Medical Lake near Spokane. Wenatchee, Saddle Rock, Castle Rock. Those are part of this. Ribbon Cliffs on the way up to Lake Chelan. Metamorphic Dikes, part of the story. The Republic Volcanics. The British Columbia, the Colville Igneous Complex. The Cooper Mountain Pluton. The Duncan Hill Pluton. Those were in the North Cascades. The Tiano, Tianoway, I guess? Fuck. Tianoway Volcanic, sorry, Patrick. Peel Point, just south of Cle Elum. Challis Magmas. Golden Horn Pluton, Sand Point, I'm not done. Liberty Bell, popular climbing place, North Cross Highway, North Cascades. Luke's nodding. And then we go over to Western Washington. Kitsap Peninsula, Granite Falls, Youngs Creek Complex, Bald Mountain, Mount Persis, that's my mountain, Mount Pilchuck, that's your mountain. Are you Ariel or Rhiannon? Sorry. Isn't this wild? I never would have connected the dots between all of those places and realized there's a regional story. There is. Okay. We turn our lonely eyes to Mr. Eocene, Jeff Tepper. How many people have been to a GSA meeting, Geological Society of America meeting? Jess is the only one. Mary has also. So let me tell you about this. See, this is a poster. So here's Jeff standing in front of his poster. Most of you are nodding now. You know what a poster session is, like at Source or whatever. But there's a big annual meeting every year, and this coming October, it's going to be in Portland. And geologists from across the country, and in fact other countries as well, come and present their newest results, newest science. And you have two options. You can either do a poster where you stand by your poster for a couple hours and you visit with people and you explain the stuff on your poster, or you give a 15-minute talk. And that's not much time. And you got to crank it out because they're on to the next speaker. There's like thousands of these talks. It's like overwhelming. Well, I'm sharing this with you because I knew about Jeff and I'd visited with him off and on over the last decade, but he gave a poster session in Portland at a regional meeting of GSA in 2019, and I was blown away. And we're spending the last part of our class with his work. Jeff has been a professor for 20 years at University of Puget Sound, and he doesn't have a bunch of published papers. Have you noticed? You're not reading papers anymore. He's got poster sessions from his students. And I think I'll post next week a few of the posters, but you're off the hook. You got enough going on with your other classes. Half of you are barely here today anyway. I can kind of sense it now. Kyle's thrilled that he doesn't have to read another paper, I think. Is it an accident you're in the high point of the room, Kyle? You're in the back row and you're lording over everyone. Is that an accident? I like to think not. So Jeff, after the poster session, was probably happy to get rid of me because I dominated. You know, I would not stop asking questions. I was just so amazed. And you'll see what he presents next week. But he came and gave a talk here to the public in this room a month later. I went and gave a talk over in Port Townsend that he hosted. And then he said, after that, he said, I think I need to find more Challis Magmas. Do you have a tip or two in Eastern Washington that I haven't been? And I said, well, how about Wenatchee? He's like, I barely know Wenatchee. I'm like, well, there's these pinnacles right above town. Bryce went right up the face of them. I didn't know Bryce at the time. Saddle Rock, Castle Rock, all sorts of other things. He collected samples with me. That's the tab photo I showed you 2 summers ago. He did geochemical analysis of samples of Saddle Rock and Castle Rock, and a couple of other kind of weird gabbros and things. And he's coming back next week to sample another spot with us. That's next Wednesday. Earlier that day, I'm visiting with a guy from the gold mine there, Cannon Mine Gold, and I'll try to relay what I learned from him. The point is, this is work ongoing, and now Jeff is kind of following leads that are over here through some of my connections. He sampled at Peel Point, the big kind of peak towering over South Cle Elum. If you know Cle Elum and look to the south, that big peak is Peel Point. That's part of the Challis. So he's got new dates and new chemistries on these local places. So do you need a picture? Okay, Jeff, hot day. I think it's supposed to be hot next week, by the way. So we're going to be cooking over in Wenatchee if you join us. It'll be just like this probably. The flowers will probably be burned off by that point. Okay, I think I'm kind of on schedule. It may not feel like it. I'm now ready to use what I learned by Zoom from Jeff 2 hours ago and look at the geochemistry and other similarities and differences between these arc magmas. Take your pick. Could be the Cascades or could be the Idaho Arc, and comparing them with our strange Challis Magmas. You know where we are. Okay. So let's swing this over here. You know, you're having a class session without food. How do you feel about that? Are you upset? You're hungry. You're wilting. You don't have that sugar. I always mean to bring in all these rocks, and I bring in these rocks. I always mean to show them. I never do. So this is Corbly Canyon on the grade up to Waterville. I don't know what you call that. What do you call that grade on US 2 from Columbia River at Rondo up to Waterville? There must be a name. It's Corbly Canyon, but it must be called something else. So Jeff has analyzed this. Rachel, I don't know if you went to his papers with this Corbly Canyon dike, but he's got a date and everything else. Here's what an andesite looks like from the Cascades. Here's some of the Saddle Mountain rhyodacite, or the rhyolite. I don't even know what he decided it was, from Saddle Rock. I'm showing you these for a reason. There's a variety. These are hand samples, are they not? These are rocks that are the size of my hand. We call them hand samples. So if we're comparing and contrasting between arc magmas, you know what I mean now, and Challis magmas, there is no difference. Diverse hand samples. Diverse hand samples. What do I mean? I mean every kind of igneous rock we have. Basalts, basaltic andesites, dacites, rhyolites. In the hand sample, all of those, as Jeff said this morning, is a calling card for subduction. I hope you know that if I say arc now, I'm talking about the subduction of an ocean plate, correct? A subducting ocean plate generating a volcanic arc. I don't have to show it to you again, do I? It's right here if you need it, that little cartoon. This guy. So whether it's the Idaho Arc or the Cascades Arc, we have, what did Jeff call it? Play with me now. Oh boy. Here. In the igneous petrology world where he lives, who can figure this out? He says, oh yeah, there's a lot of BADR. There's a lot of BADR. If this is for volcanic rocks. So cool. Basalt, andesite, dacite, rhyolite. BADR. Hey, how's it going? What kind of research you doing? Yeah, I'm working on volcanic rocks. What do you got there? Yeah, BADR. That's cool. That's cool. That's diverse. First point, there is no difference in hand sample between Challis Magmas and these others. And so for a long, long time, that's why the Challis Arc was called the Arc. It sure as hell looks like Arc rocks. The diverse, the BADR is in both categories. Let's just call it the Challis Arc. Must be a subduction story somehow. That is no longer the view. The Challis Magmas have nothing to do with subduction of a simple oceanic plate. And you're like, prove it. That's what we're about to do in the remaining time we have together. Okay, so far we don't have a difference. Well, Megan just gave us the first difference, and it's the map pattern. This is so simple. Blob scatter. How about that? As opposed to line. You know what I mean. We're on a map. What's the map pattern? Do we truly have a line or do we have a blob scatter? I don't know. What's a better phrase for that? What else would you call this? Random? Well distributed? Dispersed? I'm not sure I like any of them, including mine. Blob scatter? Okay. That's grade school. That's fine. Oh, somebody really likes something back there. What is it? Shotgun? Oh. Call on Ryan for the medicine. Oh, that's like a motorcycle. Oh, that's like a jacked up Hemi. Shotgun. Yeah, man. Gotta love it. You got to love it. Okay. Can you tell I'm stalling? I'm about to talk about geochemistry. All right. Okay. Here we go, boy. Here we go. Jeff sent me all his posters, papers, talks, notes, and I was like snowed over. Like there's plots of this isotope versus that isotope. I was like, what am I going to do? I got to do something with geochemistry to talk about these differences. Can you help me, please? He's like, here's what you can do. There was a benefit for him with us on Tuesday. He kind of knows what we're up to. Plus, he's taught for 20 years at that school and before that. So he has a sense of how to communicate this stuff. Here we go. And maybe you've heard this kind of idea before. If you are a true volcanic arc magma, you are a wet magma, as opposed to the Challis magmas, which are dry. I remember him saying dry magmas when he was talking to the public in this room a couple years ago, and I wanted to shoot my hand up right then and there and say, I don't know what you mean. I don't think anybody in this room knows what you mean with a dry. He probably defined it at some point, but I don't know what a dry magma is. Do you? Okay. Well, it's just kind of like what it sounds. Oh, God, am I going to write it all out? I'll give you the concept first. Arc magmas derive from subducting an ocean plate. We're good so far. Yes, Ariel, ocean plates are significantly affected by water. Like truly the ocean water. And in the Zoom meeting 3 hours ago, I'm like, Jeff, I can just picture somebody in the live chat right now going, what do you mean like water? Like the actual ocean water? He's like, yeah, kind of. But then I pushed and I said, could you elaborate? And he says, well, if you're out at a spreading ridge, we're out in the ocean now, we're in your spreading ridge, that's where you're generating, you're making new ocean crust. You know, some of the black smokers that are out there. Have you seen the cams underwater at the top of the Juan de Fuca Ridge or the Mid-Atlantic Ridge? There's all sorts of hot fluids, hydrothermal fluids. Jeff's point and others' point is that we are severely affecting this new ocean plate material with hot hydrothermal materials and hydrous minerals, whatever that means. You probably know more about it than I do. So not only at where we generate the ocean plate, but where we actually bring the ocean crust to the subduction zone. Do you need the cartoon again? I don't think you do, but why not? We're talking about this ocean plate generating arc magmas, but we all know it's not the actual ocean plate that's melting, right? You've been taught that in 101. We're generating magmas in deep levels of the crust above a subduction zone, but there's a lot of water that's part of this story. You're nodding your head. You're following it now. That's great. It truly does mean wet magmas, meaning that water played a significant role in the development of that magma. I'll spitball a little bit more. In 101, I teach that we are more prone to making magmas below a volcanic arc by forcing out the water in a subducting plate and introducing that water into the base of the crust. If you introduce water to the base of the crust, you lower the melting temperature and you're making melts because of that water role. That didn't seem too hard, did it? I'm talking to myself. There is no major water presence in these Challis magmas. Okay, let's stop. What evidence does Jeff see? Can he tell in a hand sample if it's wet or dry magma? He cannot. Remember, these hand samples look the same in both columns. But what does he do? He takes a sledgehammer. Did anybody watch the video? Probably not. If you watch the replay of this video or watch the replay of last video, there's a video link, and home viewers right below me, there's a link. I was out with Jeff up on P.O. Point, and he had his old sledgehammer with him, and he's breaking off rock samples from P.O. Point, and those are the size samples he's taking back to the lab, crushing up the rock and getting down to the microscopic level. He's looking at geochemistry, trace elements inside of an igneous rock. And it's at that level, with laboratory processes, that he can tell the difference. He has some signatures. He has some ways to find a smoking gun to say Challis versus Arc. And you're like, who gives a blank? I'll say it. Who gives a shit? We're going to tell some stories on Tuesday and Thursday of next week. We're going to subduct a plate. We're going to break a plate. We're going to tear a plate. We're going to subduct a spreading ridge. We're going to involve a mantle plume. We need to know which magmas, at which time, are arc magmas. These are the ingredients we'll need to follow the reasoning with Jeff's models next week. Thank you for your energy. We've got 5 minutes left-ish. Okay, here we go. There's a trace element called boron. Boron. And if we look, after doing this geochemical analysis at a tiny scale inside of these rocks, can we look at the ratio? I can't believe I'm doing this now. I didn't even know how to spell beryllium. I had to Google it. B-E-R-Y-L-L-I-U-M. So Jeff has done all sorts of chemical analyses of all sorts of Eocene magmas all over Washington for 20 years. And when I pressed him this morning for one example of something geochemically that he uses to be a smoking gun for arc versus not arc, he said, I think I've found this nice relationship with the ratio between the amount of boron versus beryllium. And he saw my eyes glaze over. He says, okay, let me help you out, Nick. Boron travels with water. We care about boron because there's an association between boron and water. We care about water because we're trying to distinguish between wet and dry magmas. And so boron to beryllium ratio, I'll write it again. Boron to beryllium ratio. Most of you are still with me. What's your prediction? Are we going to have a high ratio of boron to beryllium with the arc magmas or a high ratio of boron to beryllium with the Challis? Arc or Challis? High. Yes. It's just like it sounds. If we have more boron in the magma compared to beryllium, in other words, we have a high boron to beryllium ratio, that's a strong vote for a wet magma. A magma that was heavily influenced by water. And that's a hallmark of subduction. But if we have a lower ratio, I'll put an arrow going down. If we don't have as much boron compared to the amount of beryllium at the isotopic level inside of a magma, from Grand Coulee Dam granite, or Keller Butte granite, or Absaroka volcanics, or over by Sturgis, whatever. Apparently, almost all these Challis magmas are low in boron in this ratio, and therefore they are drier magmas. Who cares? We don't have water as a major player in the story, and therefore we can't make a case for subduction. And you're like, I don't get it. How are you supposed to make a magma if you don't have subduction? Exactly. That's next week. Do you want to put arrows, put question marks here? I'll do it. I'll frickin' do it. These are question marks. You can't even read them. You can't even read them. How are we making those magmas if there's no subduction? According to what we just said, the boron to beryllium, look at Daddy now, the boron to beryllium ratio is low. Which means they're not magmas generated by subduction, and then you're like, I don't get it. Then how are we making the magmas? That's you next week. We're making them somehow. We're not doing it now. We're following the rules. Rachel.
I don't know if I'm getting
Go ahead. Go ahead.
Is it like a compression melting story from like the extension?
We're definitely doing this during extension time. We are kind of breaking the rules. Yeah. There's models. Yeah. I want to do one more. I still have 3 minutes. That wasn't so bad. That maybe went okay. I've out of room, but let me squeeze this in. I'm using pink just so it stands out, not because it's incredibly different. The Challis magmas are hot. I'll just give you this verbally before we quit. I struggled with this one, but again, Jeff repeated a couple times. I think I got it. He says, we look at the hornblends in these rocks. You know, remember hornblende, black mineral, 60 and 120 degree cleavage planes, 2 cleavage planes, black needles inside of igneous rocks. Fine. He says, we look at the, oh God, we look at the zircon, forget wait, where's the hornblende thing? We're not going to end on this, are we? We're not going to end on the part where I face plant. Forget the hornblende. I can't find that part of the notes. Here's what I do want to say. When we are melting the crust to make these magmas, we need I got it now. We need a hotter temperature because we don't have as much water present. I'm going to say it a couple more times. I think that's actually what I wanted to say. Because we have less water, remember these are dry magmas, the Challis magmas are dry. We have evidence using the boron values. Because these are dry magmas, if we want to melt some of this, and we do, we got the magmas, if we want to make liquid, we need a hotter temperature than a volcanic arc because we don't have water to help us make the liquid. As opposed to these, which are not quite as hot, the arc magmas are not quite as hot because the water is playing a role in helping to create the liquid. Pretty sure I got that right. Nailed it. And so hotter and drier. Drier and that was a little rough at the end. I got 1 minute, even though my watch says I don't. And we're going to finish with your handout that you have in front of you, so I'll come in real tight with our audience. Yellow and red, McDonald's colors. Thank you. The red are Challis volcanic rocks. You can find Ellensburg on these. These are counties, right? State of Washington. Yellow are plutonic rocks. Remember, we got diverse. So we got gabbros, diorites, tonalites, granites. That's the plutonic side. We've got whatever the, what was that? BADR for the volcanic rocks. We've got a smorgasbord, in other words, of igneous rock types, but look at the ages. Ryan, there you go. There's a pattern to the ages. You're like, where's all the stuff down here? You know the answer. They're underneath the German chocolate cake. We can't see them. They're down there. We can't see them. But in northern Washington, go ahead and write it if you want, we have an age sweep. We have an age sweep of Challis Magmas, Challis igneous rocks, 52 million years ago in the upper extreme northeastern corner of Washington, sweeping down to 44. Generally, now we're going to see some exceptions that are troubling, but generally we have this very intriguing, this is what stopped me at the tracks at that poster session in Portland with Jeff. Like, hey, how's it going, Jeff? Pretty good. Oh, tell me about your research. I'm like, what the hell is this? I'm like, zeroed right in on this. There's a beautiful 52 to 44 million-year-old age sweep pattern sweeping across our state. And of course, the answer is why. Of course, the question is why. And Jeff thinks he has the answer. And that's what we'll do on Tuesday and Thursday, with even some crazy freak out periods within the sweep. I can't hold it. I got to get you to come on Tuesday. The Teanaway volcanics are part of a break-off belt. Just a little taste for next week. Somehow, something deep beneath Washington is going to break off. And our beloved Teanaway volcanics north of town are going to be part of that break-off. And you're like, I don't know what you're talking about. You're like, you're damn right you don't. We got 2 more days. Enjoy your long weekend. I hope you get a chance to visit with family and friends. If not, I hope you enjoy your solitary times underneath the maple tree. And I will see you on Tuesday. I love you. Thank you. And goodbye. Thanks for being with us. We'll do some live Q&A in just a couple of minutes. Stick around if you like. I might hold you off too with the rule, but we can talk about what we talked about today. Thanks. Ariel.
So kind of a question with the subduction magmas being not as hot.
Yeah.
Is that also why we typically see the magmas that come out of stratovolcanoes? They're not as hot as we see with, like, besides like the age of the volcano and that kind of thing. Is this another reason why we see the lavas that come out are not liquid glowing lavas? They're dull, they're darker, they're cooler. They come out more as rocks and that kind of thing. Is this like, if it also plays into with like the age of the volcano?
Let's just say we have different volcanoes in different settings, and let's say they're all currently erupting. Just so we can take age out of it. Let's just say they're all active. We do know that mafic magma is a higher temperature, and I think we can generally say that that's because we're getting mantle material up to the surface in a hurry. And so we can think of crust that magma has to negotiate as essentially cooling things off a bit. But as soon as I say that, I don't think I'm right. So I don't really know.
Well, because I know there's a stratovolcano that's erupting. It was erupting like it was the one in Italy.
Yeah,
That was
okay.
erupting liquid red lava, even though
Yes,
it's a stratovolcano.
right.
And I was talking to Professor Keegan about it, and
Uh-huh.
she was saying how it's on an island, the crust is thinner, so it's more likely to erupt the basalt similar to a shield volcano, but because it's still a stratovolcano.
I'm really
it's
weak
not
with
as-
that stuff. Yeah, I see where you're going, and we'll do a little bit of kind of talking about crust thicknesses and the role of the mantle. That will be a big thing on Tuesday, but I'm not ready yet, so I don't.
It's like one of the I love volcanoes, and so I've always wanted to try
Sure.
to find out like why is it that some stratovolcanoes don't like they erupt different magmas. Like,
Well, it's a good thing Hannah Shamloo's coming in December.
Yeah.
Yeah,
Yeah.
wonderful.
You're
Kyle?
lucky. I'm not lucky because I'm
Hey.
leaving. I'm graduating.
With these Challis Magmas,
Yes.
do they continue into Canada, or is that just not surveyed yet?
In British Columbia, which is part of Canada, they do. So the Kamloops magmas, and I said something else I can't forget. So they extend a bit into BC. I don't know about Alberta.
Okay.
Yeah.
Yeah, and maybe into Saskatchewan.
I'm sure they've got good maps up there. So I have no doubt of that. So it's just a question of looking up there. So maybe there are some good Canada Challis magmas as well. But
yeah,
I'm just starting to get hip to this. Kyle.
Okay. Is Mount Spokane part of this?
That's the only way for the class to change.
I saw
I
blobs.
don't think so. I think that's a granite that is Cretaceous, I believe.
Okay.
So a little bit too old. So that's something I didn't mention here, but there's also in amongst the Challis magmas, there are plenty of Cretaceous magmas that are some related to the Idaho Arc, but some are part of this Baja BC thing. Like Mount Stewart is granite, but it's not part of either arc. It's been this long distance transport.
Because
story.
Mount Spokane's a good high point. 5,800.
Oh, there you go. You got such a one-track mind. It's too bad you're not a foot taller. You could really just be at a high point your whole life.
I'm
Thank you,
still
Kyle.
taller than most people.
Yes, you are. Let's not sell you short. Jess.
I was curious, do you know this far out if you'll be teaching any intro classes in the summer or in the fall that I could sit in?
You're welcome to sit in on my 101, which is every fall and every winter.
Wonderful.
Yeah.
You don't teach in the summer?
No.
Okay, gotcha. Well, I'll be looking out for that in the fall.
Please do. Yeah. The same room, same whole thing. Yeah.
Cool.
Yeah.
Awesome.
Nice. Thank you for your interest. We good?
Nick, you can't leave us on this kind of a cliffhanger.
Sure I can.
Why the heck is this, are they? How are the magmas moving, like getting younger as you go southwest?
Do you have an idea?
No, I have no idea.
Oh boy, you're bothered by this.
I'm really bothered by this. So I'm bothered by if you're accreting Celestia at the same time. How are you extending the crust when you have more material jamming the subduction zone than normal?
Right.
Right. I would think you would get much more,
Right.
especially when you get the point per section for the Tiano basalt. So that's number one.
Okay.
And then if the plates doesn't change direction, right? If North America doesn't start going backwards and it's still going, southwest.
Yep.
How are we bringing either? The only thing I can think is the heat source is coming from the northeast and moving faster than the plate, but I don't. Where are we going to get that from?
I want you to sleep well this weekend.
Yeah, please.
Ryan, I'm concerned about you now. Okay.
There's just too many things. You
So
dropped too much
I
on
want
this
you to
one.
Google one phrase, and that's
Okay,
all I'm going to
okay,
say.
Okay.
Slab rollback.
Okay.
Have a good day.
You too, Nick. Thank you.
Thank you, Matthew.
So I'm thinking about the observational data from outcrops
Yes.
and how like hydrothermal fluids and fluids in the magmas, you can sometimes see that in the outcrops
Yes.
through. I'm thinking of an example in volcanology, rocks and minerals. We went up Icicle Canyon.
Yeah.
We saw these amphibolites, these hornblends
Okay.
that were 10 centimeters long.
Wow.
And Wendy was saying that she was thinking it was hydrothermal.
Uh-huh.
Do we see, do you know of any good examples that we can use to separate the arc and the Challis magmas?
Not yet,
Not yet. Okay.
but I don't know if I will next week, but I keep coming back to the fact that we have gold and silver deposits with these Challis magmas and typically not with the Arc. Now, that's maybe not right. And so if that's true, then we have way more hydrothermal fluids associated with the Challis magmas, creating micas and other kinds of hydrous minerals. Maybe I couldn't find my notes, but the hornblone's part of this somehow.
Yeah.
So what you were looking at with Wendy, wrong kind of rock, of course, but that idea of hydrothermal fluids and alterations, it's a regional alteration of these rocks.
Right.
And I don't want to get your hopes up there because I don't think I'm going to have it for you. But it's
That's
cool
fine.
you're connecting that. With
I
your
was
field
just
trip.
curious.
Yeah, man.
Curious.
Yeah, very good, Matthew.
Thank you.
You bet.
So what kind of magmas are these? Are they more mafic, more felsic, more intermediate, or are they just
Diverse. Everything in the kitchen.
BADR?
Yep, BADR. You heard it here first, Hayden. All right, you guys, I'm glad you're into it. Thank you. Ree wants to say one more thing.
I was wondering if I could have a quick advising appointment with you sometime next week.
Next week? Sure. Monday? No, we don't have school Monday. Tuesday morning at 10?
Yeah, I'm a little concerned about my math. I don't know if I'm going to be able to get my calc tool over the summer. So,
You want to come back to my office in half an hour?
sure, I'll be
I'll see you in 2:30. Good, thanks. Okay, thanks for your patience. Goodbye, Hayden. We may still have Jeff, who has probably been answering a bunch of your questions. Can I get to live here? I can't. I've never noticed that. I've always been in top chat. Okay, uppercase questions. We'll see what I can do. Now, remember, I don't know. What should I do? Should I give you all the stuff from next week? Or should I hold off like I did with these guys? Let's answer that first. What's your vote? Should I give you sneak peeks of what we're doing next week and do models and all that, or do you just want to be waiting like the students are waiting? So yes or no? Tell you all the secrets? Yes? Or tell you all the secrets now? No. I'll wait for that. You've already been waiting so long. I'm sure most of you want to talk about that anyway. Yes or no? Do all the models and everything now? Or no? Don't do all the models and everything now. Where's all the comments? What happened? My chat just froze. Here we go. Yes, 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 yes. No, no, no. I forgot my question. Oh, shit. Oh, gosh, it's a split vote. All right. Okay. Stupid thing to ask. Of course, there's going to be a split vote. I'll do a little bit. Okay. We'll split the difference. I'll do a little bit of next week with you now. So, my chat is freezing up. I don't know why. Never had that before. And I don't want to. So, go ahead. Would you type in your question again, please? And I'll try to find a happy medium. And if you really don't want to hear any answers from next week, I guess, thanks for joining us. We'll see you next Tuesday. But, okay. Would you mind typing? God dang it, what's going on? I'm frozen. I can scroll back. Well, Chris is answering. So I'm sure some people in here already have the answers and they can't hold it themselves. Okay, thank you, Kyle. Kyle Roth, do Challis magmas age progression generally get older going east into Idaho, Montana, and Wyoming and South Dakota? You're asking Jeff. Pretty sure the answer is no. The age progression that we have is the age sweep that we're talking about is most exciting and most clear in the state of Washington. I'm confident in saying that age progression does not get older and older and older all the way back to the Black Hills. But if you're asking for details about the ages in those other states, I don't have it. And Tepper says no. Somebody reports. Hotter magma means deeper source, right? Okay, so again, we're jumping ahead to next week. Okay. So I have more reading to do. And again, Jeff might be answering everybody's questions. I'm not sure. But we somehow have to make these Challis magmas without subduction. And I don't have it all in my head yet, but the general idea is that we take some of the mantle and we get it into shallower levels of the crust than it should be. Now, maybe I will be coy about how we're doing that, but I will say that with you now, that we're getting hotter, drier magmas independent of subduction. We're getting Challis magmas by getting some mantle leaks up into the crust and generating hotter, shallower magmas. Jeff can correct me in real time if I'm screwing up. Now I'm scrolling. I think I'm back to live with the chat. It's kind of freaky. I'm just looking for uppercase. BC Outdoorsman, do both the Challis magmas and Arc magmas form plutons? Or do the Challis magmas just form dikes and sills? As I understand it, there's plenty of plutons and lavas and dikes and sills in both categories. Now that I say that, I wonder about the dikes and sills. And certainly there are some small-scale dikes within a volcanic arc, but maybe this is more of a regional kind of, like 400 dikes like the Teanaway. Maybe we are more prone. Maybe Jeff can weigh in on that. Saber, how would I recognize a Challis magma in the field? Well, that's one of the main things I learned from Jeff this morning, Saber. The rocks, as you hold them in your hand, they don't look any different. I didn't really have that till this morning, courtesy of Jeff. Basalts, andesites, dacites, rhyolites, basalts, andesites, dacites, rhyolites. You want plutonic rocks? Gabbro, diorite, tonalite, granite. Gabbro, diorite, tonalite, granite. All those rocks in a hand sample look the same, and that's why everybody was calling it the Challis Arc, just assuming it was another subduction story. But again, if we go down to the invisible, if we go into, I'm sure, Saber, you don't have your microscope and your tweezers and your analytical lab in that car of yours. Hell, you don't even have your power source yet. So you can't just look at an outcrop and say Challis. Thanks for the question. Jerome, is the Challis magma age progression due to a southward moving spreading ridge? Good thought. How can I be half truthful and half coy? Jeff's model next week is not going to involve a spreading ridge to explain this pattern. I gave Ryan, did you hear what I told Ryan? Because he was really bothered. He needed something, otherwise he wasn't going to leave this room. Jeff has a breaking of a ocean plate that has subducted and rolling the plate down. I don't expect for it to make sense to you, but if you have trouble sleeping this weekend, maybe this can help. Google the phrase slab rollback, and that's where we will go next Tuesday to explain our age progression, courtesy of Jeff and others. Maybe just Jeff, I don't know. What is slab rollback? Well, you're just going to have to do some reading, Kent. That's as far as I want to go there. Pat, is there field evidence for the higher temps to make dry magmas, or are the differences microscopic? Is there field evidence for the higher temps? I think it's a microscopic thing as I understand it. I'm down to live, I guess. Charlie, can a plume decide to rise out of the mantle without a slab reason? Can a plume decide to rise out of the mantle? Well, there's basics of plumes and hotspots that we don't understand, but it appears once you get this mantle plume going, it's hard to get rid of it. We will not have a mantle plume underneath Washington to explain these Challis magmas. How about that? I know the Yellowstone mantle plume is peripherally part of the story, but as I understand it right now, the Yellowstone mantle plume is too far south. We're not going to have a mantle plume right beneath Eastern Washington. Or right beneath, let's go to the map. This is fun. I'm glad you guys are sticking around. I don't know, maybe you're frustrated with me. I don't know what to do if you are, because I haven't read that far yet. What was I going to do? Oh yeah, but you know what? Jeff is still with us, I think, and Jeff's not going to be with us live next week. He's going to be in Wenatchee collecting samples with his students. Yeah, Jeff is still there. Jeff, would you mind breaking away for a second? I don't know if I can catch your answer live in real time or not. But we've been talking about the spreading ridge, Jeff. Here's my arm, the spreading ridge between Kula and Farallon. And this will come back, everybody, next week. And we were talking, I'm mainly talking to Jeff now, but I guess everybody, we were talking about the Yellowstone mantle plume straddling the spreading ridge. So why don't we have a discussion of the Yellowstone mantle plume beneath the Challis magmas, beneath Washington, let's say? Especially if North America is drifting to the southwest. I'm just realizing this right now. Like, I'll say it another way. This is totally experimental now for those of you that have stuck around. As I've been teaching the Yellowstone mantle plume, it's been off the coast of California. And North America drifts to the southwest, and the Yellowstone mantle plume, with the flashlight that I had in the tracing paper, it's kind of a straight line between here and Yellowstone. We can all agree generally with that if the Yellowstone mantle plume is fixed and the Yellowstone mantle plume is there now, it's a straight line between the two. Okay? And then I say in my general teaching, Siletzia is up here, not because the Yellowstone mantle plume was up here, but because since Siletzia was made by the Yellowstone mantle plume and accreted, it's been moved up to Washington and Oregon. I think I just answered my own question. So we're never talking about the Yellowstone mantle plume beneath Washington. Because of this straight line and rotation of stuff related to the Yellowstone mantle plume that's up here. I guess I'm finally on it. Don't some of Ray Wells's maps have the Yellowstone mantle plume slipping beneath Tillamook? Oh, but the Tillamook, oh, I see. The Yellowstone, forgive me, man, I'm just a guy in an empty room talking to himself. I think I'm realizing right now, when I always talked about the Yellowstone mantle plume slipping beneath Tillamook, Oregon 42 million years ago, I visualized Tillamook, Oregon, like present day Tillamook, Oregon, but Tillamook, Oregon was down here. It used to be Tillamook, California, har, 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 and now it's Tillamook. Okay. I think I just answered my own question about why we are never going to entertain the option of a Yellowstone mantle plume beneath any of these Challis magmas, even though some will still be insisting on that next week, I'm sure. Boy, entertaining myself now. This is a new level of narcissism. Cindy, could burning through a broken slab cause hotter magma at a shallow level? That's really, we are going to have a broken slab, Cindy. I don't know if you've read on your own or just thinking in real time, but we're going to break the Farallon plate twice. I can't hold it. Again, this is our last time with Jeff live in the chat room here. We're going to break the Farallon plate twice. And each time we break an ocean plate underneath us, we have the tomography to prove it. Each time we break that Farallon plate, we're going to send a bunch of hot mantle up through that gap and trigger hot, dry, shallow magmas. It's fun. Ivana, the Brooklyn Savant, is with us. Hello, Ivana. Still fishing for uppercase. We'll do a few more. I'm having too much fun. Going to a party tonight. One of my wives. I only have one wife, I think. Someone who works with my wife is retiring. So we're going out to his house and going to have a big old party. I might have an extra one or two. I got nothing to do tomorrow for this class, so I might live it up. Might have to take a nap first. Okay, I don't know. I'm down to live. I'll try to do 3 more questions. Jeff is still with us. So yeah, Jeff's getting into it, looks like. Breakoff of slab was necessary for trench to shift west of Soletsi. God bless you, Jeff. You're doing it all. I don't want to do all the diagrams and everything now. Otherwise, what's the point? Vana's not in Brooklyn. He's in Manhattan. Okay. I stand corrected. BC Outdoorsman, are you going to get back into near trench magmas again? Can you forward any other papers regarding the near trench magmas? We are circling back to the near trench magmas. Again, Jeff helped me this morning on the Zoom call. He made it very clear to me what an adachite is. I said, are adachites just talking about a spreading ridge subducting? He's like, no. Adachites are melting the ocean plate. And I'm like, what? And then I wrote it out, melting of the actual ocean plate. That's not what you do in a subduction zone. You don't melt the ocean plate. You generate the melting above a subduction zone. But the adachites are actually like destroying the ocean plate. So we will do some adachites. We will talk about a subducting spreading ridge. We will do a little bit with near trench magmas. So I'll try to find that pattern. I don't know if I'm going to go back to Mike Eddy's controversial southward triple junction. Jeff really respects Mike Eddy, but Jeff wasn't seeing why Mike had a southward migrating triple junction. So I don't know if I want to go back there or not. Papagino, were the Challis magmas less energetic than the arcs? Less energetic. Less energetic. Interesting question. We've emphasized that there's all silica types and all rock types, whether you're Challis or arc. And I guess that means you're going to have just as much volcanic hazard with Challis magmas as you are with arc. I mean, the bimodal is bimodal for a reason. We've got the most explosive rhyolites you can imagine. And I guess caldera's associated with that. Although these are so old, I don't think we have Challis aged calderas mapped out. I'm having a good time. I don't know about you. We still got more than 600. Not bad for a Thursday afternoon. Chris, are there any Challis-like magmas further south of the hotspot track, like Nevada? Well, I'm reminding some of you, you remember that I'm having a great time here, but I know I'm not going to get to all these far-flung Eocene issues, but I will be doing more of this from home, I guess, later this year. This is basically a sweep, an age sweep. Did I call it age sweep? I guess I did. Some people call some of this flare-up, an ignum bright flare-up. And I think in the time we're talking about, there's an incredible sweep or flare-up of high silica rocks like through Nevada. I don't know the timing of that. It's maybe a little younger than our Challis story, but I mean, I think some of this sweeping might, like somebody was asking about getting older this way. I don't think so. I don't know. But I think there is some sort of like general north to south sweeping all the way down to Vegas. I just have little fragments here and there, which is typical. Are the tufts from the Challis? Well, remember now, Charlie, we're talking about everything. I did that whole roll call of places, including the Teanaway, including some of those young plutons in the North Cascades. They're all quote unquote Challis, even though they have individual names like Golden Horn Batholith. So yes, they're part of the Challis, but I'm not saying that. I hope you know that when I say Challis Magmas, I don't just mean the volcanics around Challis, Idaho. You must have that by now. 2 more and we're done. Dave, what is the delta between boron beryllium ratios in wet and dry magmas? Jeff? One more. I'm scrolling way back. Oh, Jeff is, I'm getting all these. Jeff, I'm going to be very interested in what you have to say to these guys. And thank you again, Jeff, for joining us. This is a real treat. We'll finish on this. Dennis, is the breaking of the slab related to the trench moving to the west of Silesia? Yes. Ryan wanted to go there. I shut him down. I could feel the hurt in his eyes. Yes, we know the main event. Like fans from the Exotic Terrain series, our main event was 100 million years ago with the accretion of the insular superterrane. But I'm stealing that phrase, the main event, and for this class, the main event is 50 frickin' million years ago when we accrete Silesia. Everything going haywire. We wouldn't have it if we didn't dock Silesia, including the breaking, the rollback, ... coming next Tuesday and Thursday. Before I do a toast, I've had 3 different people ask me to show you the classroom. Like all you see is this corner. So there's nobody in the room. Why not? So let me give you a quick little pan. Just, if it was just one person that asked, I'd kind of ignore it, but the students have a projection of the document camera that's next door here. Can I do this without twisting up my whole setup? Hayden sits in the back. Kyle sits in the way back at the high point of the room, of course, so they watch on the televisions. There's the document camera. There's the wine. A toast to you. Here's to you and your ongoing intellectual curiosity. You are inspiring to many of us for wanting to continue to learn new things. Here's to you. Here's to the students who have been in this class. I hope they know how sincere I am, even though I like playing with them and teasing them and mocking them on occasion. There'll be more of that in the video from the old Blewett Road, which I'll post this weekend. We did that yesterday. I try regularly to make sure on other moments that I can be sincere with them and know that I am very fond of each of them. They know that. So therefore, they, I think, understand my humor. So here's to the students. I'm getting a bunch of emails about what's happening this summer and that sort of thing, and I appreciate all of your interest. I will, I guess, make some kind of vague announcements next week about what's coming down the road, but it'll be vague. I need a break. I'm really enjoying this class, and I'm enjoying learning all this stuff, but 200 programs in 14 months, that caught me by surprise when that was announced yesterday. I never thought to count them up, so time for a break. Can I take a break? That's the question. I got to go advise Ree in my office. So I will say thank you. Hope you enjoyed this one. And look for an old Blewett Road video posted sometime this weekend. Our boys are coming home for the weekend. Corey, the girlfriend's coming home, so we'll be busy with them. But I'll find a little time somewhere to edit that video and post it. And then I'll see you for the thrilling conclusion of Geology 351 next Tuesday and Thursday. Thank you, Jeff, for joining us. Jeff, I'll see you in the flesh next Wednesday over in Wenatchee. Goodbye, everybody. Have a good weekend. Thank you. I love you, and we'll see you next week. End stream.